and I'm here today to talk about policing the capital markets with machine learning. And of course, you can see the background of my house, and I have some kids playing video games around the corner, so I'm hoping it doesn't interfere, but I'm going to flip the slides here. And I'll give a little bit about myself. I've been coding for about 45 years, 40 years building compilers, 35 years doing distributed computation, 30 years doing OSs and device drivers and high-performance computing. Of course, I did a lot of work with Hotspot. I sort of made jitting possible in a way that the world had never seen before. Low latency GCs, custom Java hardware, now blocking hash maps, 20 patents, hundreds and hundreds of public talks. So I've done lots and lots of stuff in the world. In the last couple of years, I've spent looking at the public markets and helping people look for fraud in the public market. It's safer. So why do we care? Well, the public markets are where 100% of our economy is basically valued and priced. So why things are worth what they are is all about what the public markets, the stocks and the options and futures and commodities, what these things say they're worth. The vast majority of this trading in these markets is done with computer algorithms. High frequency, not low latency. Separate out low latency, that happens too, but high frequency trading. Lots and lots of trades done. And it's done not just in the stock markets, but in the commodities and foreign exchanges and equities and in all kinds of markets. And nearly none of it is actually policed with a computer. It's all manually, the trade surveillance is all done manually. Okay, somebody asked, what's the difference between high frequency and low latency? High frequency means you're doing a lot of it, and low latency means that you need your answers back in microseconds and below. So the people who play the nanosecond race games, they're often, the Flash Boys book talks about people doing basically front running, where they see a trade happen in one market and they're trying to beat somebody to the punch in a different market, and it's all about speed of light. Whereas high frequency is simply doing way more trades than a human would typically do because there's some sort of sophisticated algorithm they're trying to accomplish there. Okay, so Neurensic, the name comes from market forensics, reads the stock ticker tape and looks for illegal activity. And now Neurensic is not a law enforcement company. We build tooling, and the tools are used by regulators, by mutual funds, by traders, by hedge funds, all kinds of people. So it's not about trying to enforce the law. It's really about visibility. So we look at not just the New York Stock Exchange, but maybe tickers from the Chicago Mercantile Exchange and the London Stock Exchange and Hong Kong and the Japanese and everywhere in between. The data is big. So worldwide, there's probably 1 trillion rows of data, or say a row, a trade activity, about 1 trillion a day. A big firm might see 1 billion rows in a day, but a more modest size sort of normal firm might still see 10 million trade activities, 10 gigabytes daily. And so there's a need to run some sophisticated ML algorithms to go find people who are doing bad behavior. So what is bad behavior? Well, Dodd-Frank law passed this law that said it is the intent to deceive is illegal if you are attempting to deceive somebody. Okay, so Neurensic builds tools. We do not declare intent. That requires a judge. So instead of declaring intent, we bring up results couched as a risk factor from 200 to 800, where the risk is your odds that your behavior you're doing is to be considered illegal. Basically, we compare what you're doing to activities in the market that have been already investigated or prosecuted, right? And so we're using machine learning to find close matches to patterns of data. And once they're found, investigation by a compliance officer is generally the next step. So we're not doing anything about enforcement. We are merely the flashlight in the dark. So like I said, it requires a legal system to declare guilt. So instead of trying to declare criminal activity or not, we have to help everyone understand the data. So we are presenting the data to the judge, the prosecution, the defense, everywhere along the way. And we're trying to, machine learning is notorious for being opaque. So we don't try to justify the results in that sense. We find interesting patterns and we show them to people. So we know what the trading firm knows, the internal audit logs, the trader's activity, his attempts to trade, his position, accumulations of stocks or futures, his buy-sell offers. And we know the public knows. So the ticker data, which is a bid-ask spread, the volume traded, canceled order offers, historical trends, And we have to filter these down to a human scale. Billions of rows of data become merely hundreds of rows of data. And we also have to hand it back the actual audit log files or ticker files, not the machine learning results, because the actual raw data is both understood by all the experts in the field. It's also hard legal evidence, and ML results are not. And the data is messy and it's big and symbology changes over time, and you have to do all kinds of stuff to make it presentable. But then we present the patterns. We show the trades that are going on. We show them in real time. We show them in slow time. Matrix style, tick by tick bullet time. We can match trader positions and activities with bids and offers and cancels. We can show the book of outstanding offers. We can make visual movies of the above and present them sort of as here's how to understand the data. And then we show you the raw data that you can validate what we're showing you is what actually happened. And once you get a belief that the tool is showing what really happened, then you can use the visualizations to understand whether there's criminal activity or not. So we went through a lot of rapid evolution of displays. All kinds of better and better and better visuals, or better and better filtering. There's always this tension between too little and too much. The legal requirements have changed over time. And sometimes we had just needed a new display to display a new pattern of bad activity. An old pattern no longer happens, but a new one emerged, and you have to change how that works. So we ended up moving the displays from a rich desktop to the browser, and then from the browser you can go mobile. There had been a thick client desktop when I got to Neurensic, but the browsers are everywhere. And you can bring HTML safely through firewalls to a VPN connection. And that means that you can send the results to wherever the compliance officer sits. And sometimes he's sitting in the office of the CXO or a lawyer or a judge, showing behavior or explaining why behavior is safe or not safe. And so he can bring that information through a firewall to his laptop. And the data itself, the raw data, typically sits inside a corporate private data center. There's been some noise about people moving data to the cloud, and that's happened in a few cases. By and large, like the far majority of the common cases, that data represents the company's crown jewels, and they are not letting it escape their corporate private data center. So the server for this product sits inside the firewall next to the data, but the client is in many, many places. So here's a top-level architecture view, and I'll do some drill down here. Somewhere in the world, audit logs show up, and these come from the result of trading activities of various kinds. They are legally required to be stored in permanent storage for like 7 years. So they go somewhere to a write-only drive, and they might sit somewhere for a while in some faster internal storage. And then there's these score servers, where score is this product doing this compliance. And this is a bunch of H2O base nodes. I'll talk about that in a minute. Typically sitting on-premise. They can be in EC2, but they're typically on-premise inside the corporate firewall, where we go to Amazon, to S3 to pick up public market data, but the private data is in the private cloud, and that's where the server sits. The machine learning's run on the server. Results are also logged back. There's a legal requirement that those results be saved for like 7 years in write-only storage. And then the H2O server does a second duty, and that it brings together the slices of the data that you're looking at with the associated public market data and all the machine learning results out to compliance officers, to browser viewing. So there's a rich API to a browser client that's doing all kinds of fun viewing. So why do we use H2O? Okay, I was a co-founder of that company, but it's a really great open source ML tool. And the data sizes involved are easily within H2O size. So a modest, pizza box server will easily handle a 10 to 40 gig data set. A 256 gig server will handle a 200 gig data set. And I've totally done that. It works really great. And you can get a terabyte on a modest cluster. The ML algorithms are bleeding edge, state of the art. We have direct hooks into Python and R, and this is sort of we use that directly. We took the data science work, was all done in Python, and we're running the Python directly in production using H2O. So here's a little more drill down in. There is an audit log that came from somewhere, and it's usually a giant, messy CSV. It's very messy, has all kinds of weird issues about it, and these things run into the tens, hundreds of megabytes and beyond. We load it into H2O, and it's a CSV, so you get a 2D table. You might think it's sorted by time. It's typically not, because data race is involved in logging the loggings out of order. Fine. You go through some ETL steps. Again, I'm going to drill into each of these steps in a minute. ETL has maybe 100 different individual steps that are done to clean the data up. So there's a lot of cleanup work that has to happen. We then sort the data in a couple different ways. There's usually a time sort, but there's also a sort by instrument, or by exchange, or by trader, or by account, or whatever. And then we get into the parallelized Python. And there's two pieces of it. There's a clustering piece that reads the sorted data and breaks it up into clusters of activity, where some set of trades are now considered one single intent by a trader to accomplish something. And then we run machine learning on it, and the machine learning might look for spoofing attacks or abusive messaging. That's one where you spam the exchange, trying to slow it down by a high volume so you can get something done somewhere else while the exchange is lagging. Wash trading, cross trading, where there's a lot of them. And then we get these risk results out, and the risk results go back to a file, which then the client ends up having to save for like 7 years for legal reasons. So let's go back and look at the ETL steps. We read these CSV files, and that's just straight up using H2Os, read a CSV. But then we look at the data, and there's about a dozen different vendors' formats we understand where this audit log file came from. And based on that, we do some vendor-specific ETL. And again, there's maybe a couple dozen passes with hundreds of individual cleanup steps. There's all kinds of like drop missing or imputed values, or look at data and recognize that it's broken so you can't use it. There's a lot of normalization that has to happen. Different vendors use different names for exchanges or products or how they store prices. Different traders and account normalization. There's a lot of token mapping where some vendors use the letter B for a buy and others use a capital buy. The word limit for a limit order versus LMT versus L or K or 2 or whatever. There's hundreds of these stupid steps you do to get this all normalized. Once it's normalized, we go ahead and sort it. And then from the sort, and that's an H2O call, we just say go sort this terabyte of data, and it's done. And then we go do this Python-specific clustering, where we break the data up sort of arbitrarily without understanding what a cluster is using H2O, and we run parallel Python on chunks of data. And then each CPU does roughly the same amount of work, but they decide where the lines are between respectable clusters of activity. So why are we clustering in Python? Because the data science team decides what is an intent. They decide what's a good cluster boundary. And there's a pretty clean interface with Python. It's start a row, start a new cluster, keep it or stop a cluster, or drop the row together, whatever. But we're going to run it in parallel on big data, and so we're using Jython to run the Python in parallel. Any one CPU is handed maybe 100,000 rows. We'll build 1,000 clusters, 100 rows each, and except for the edge cases, the one CPU is just running Jython sort of directly through the cluster, looking for the conditions it decides how to break up a cluster. The clusters are typically the same instrument. So here I have, NDAC versus Apple in my example, but not necessarily. The clusters are supposed to represent intent, and that varies by what illegal activity you're looking for. So a wash trade is typically 2 rows. 2 guys are swapping a stock back and forth to give the illusion of volume when there's nothing happening. There's no money trading hands, or keeping the same price. Whereas abusive messaging might have 10,000 messages in it, well, that's where you're spamming the exchange server. And a wash trade might be over in a millisecond in time, and the spoofing attack might take 5 minutes to build up. So the clusters do vary widely in size, several orders of magnitude, but it turns out that the load balancing works out pretty well here, that we get this nice breakup of clusters, across the, I'm reading questions here, across the data set. What kind of behaviors? Okay, so we are defining the behaviors based on experts in the field telling us this behavior is illegal and also considered a risky behavior that needs looking at. So it's not that you can't define your own strategy, it's that my company was doing the data science as well as all the data cleanup and filtering, as well as all the legal issues with managing the customer's very risky financial data. There's all kinds of rules about how you handle the data and where you can save and store it and so on and so forth. So, you know, the product's not open source. H2O is. You could do the same thing in H2O, but I couldn't hand you the system. And the people that are our clients themselves were not interested in writing their own strategies, or if they were interested in that, I'd be willing to go work them through what it is we had to do. Okay, so let me get back to my talk here, and I'll watch the chat window again in a minute. So once we've broken up into clusters, we now go back to each cluster and we run the clusters again with a new Python script doing the machine learning, actually. And so each cluster is run in parallel, but within a cluster, the clusters run sequentially. And then there's lots of these clusters and they vary widely in size, but we do this load balancing with H2O, which works out really well actually in practice. We typically have 100,000 clusters of, orders of magnitude difference in size, but because of load balancing, that all kind of works out in the end, fairly reasonably. And an individual CPU runs a Jython over an individual cluster to go do something. Why is it sequentially even within a cluster? And that's because the market is inherently sequential. Person A puts a price out for stock X, person B reacts to it and buys and sells, person C reacts to that and changes their price, person D does whatever. That's one person does, and then the next, and then the next, and the next. And it's a sequential market. So a spoofing attack, a detector for a spoofing attack has to have some sequential component where it goes through a set of trades, one after another, watches for places and fills on both sides of the market, looks for large positions on one side or the other of the market that might be pressuring the market, then a big cancel, which causes the market to rebound, and then reaping fills as the market rebounds. But these are all time series data. This is in order. So you can be parallel across clusters of activity. Within a cluster, you're in order. And it's, like I said, the models can be pretty darn sophisticated. But because you're running Python in parallel, you're limited to what Python can be parallelized. Yeah, okay. So Python sees an entire cluster as an array, a 2D table, an array of rows of data, just filtered down to the data that's interesting and important and put in the right kind of orders for it to go deal with. And so we're limited to what we can be parallelized in Python. So there's like no global variables, but function locals are fine. No native library callouts unless they happen to be thread safe. There's a few of those we use. Most local self functions are okay. Most generic Python's okay. So the data science team has some constraints on the Python they write, but mostly they have a free hand in writing the Python. Okay, and here I'm going to make an effort to switch to doing a live demo. And then I'll be done with the official part, and I'll just do Q&A until we get kicked off here. So I'm going to screen share and change to this. Okay, so here I am. I'm going to take a look and see if I can find some highly anonymized data I have here. And I'm going to load it. Okay, so what I just did was I loaded a file that was a raw data file. I didn't actually load it yet. I loaded the risk file for it. And this particular file represents a smaller file of a client that eventually the traders involved got prosecuted and went to jail. And so the details of that, or some of the details were public. This particular data set is sort of loosely related to that. We took the actual data, we changed all the names and times, we skewed around the times of the events happening internally so you can't sort of fingerprint the file, where we did a lot of stuff to anonymize. But you can go look at the Wall Street Journal and figure out who this is if you have an idea here. So the heat map here in the big box shows individual traders. I can sort by a lot of different things. I'm viewing 215 clusters. Typically, I'd see 10,000 up here, but I've picked this one for a demo. There's a bunch of different breakouts of data of what kind of activities you're looking at. And it's color-coded by how risky the behavior is. So if I drill into Boba Fett here, I have clusters of activity. I have like 140 Boba Fett clusters. And they go down to green, meaning like, yeah, he did something, but it wasn't any big shakes, up to like, okay, wait, there's something going on here that we want to worry about. And on the left here, I can see, wash trading versus spoofing versus whatever. And I have on top, I have a lot of filtering options. And this is because it's like this filtering of a huge amount of stuff. So here I am drilling in a little bit more on a cluster, and I can see the start and stop time, the traders and the instruments and the accounts and the file where the data come from. Now I'm going to load the actual raw data file into H2O. And at this point, I'm loading a 100 megabyte file. It's 200,000 rows of interesting stuff. And then I've gathered the rows in question for the cluster, and I bring them out into a blow by blow where all other activity happening at the same time on the market is filtered away. So these rows are not sequential. They represent activity by this trader in this log file, but there are gaps in here if I go find them. It's pretty tight. So like here's a gap between this line and that number. But I can go back to the raw file and see this exact data minus all my cleanup. So I've done some neat thing with the time. I've picked up nice names for the, you know, cancel, sell, order, buy, whatever. I've pulled out your global position over time and price and blah, 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 lots of things. Top left, I have some high-level overviews that are useful for a compliance officer, including things like the ratio of orders canceled to orders placed is 50%. Half his orders canceled. Because that's unusual, and it's kind of one of the with spoofing attacks, but it's not the only requirement for spoofing attack. This particular cluster is 289 messages, so about 300 rows in my little scroll bar here of raw data. And it took place over 16 seconds. And here's a timeline down here where I can see in sort of a overhead view that he's building up one side of the market pretty big. He builds, he builds, he builds. And then at these black arrows here, he does a market flip where he cancels a bunch. And I can see the time down at the bottom here. I'm pointing at my finger, you can't read it. I can go find the time in the raw data file here. And if I scroll down through here, oh, look, here's a bunch of cancels, one after another. He completely canceled one side of the market. He adds to the other side and gets fills on the other side. And if you look, the fills on the other side are at a higher valuation that he spent to get here in the first place. He gets a 10% discount on thousands of dollars. So he gets hundreds of dollars in 16 seconds. And then he turns it around. He does it again and again and again and again. And so he's making, you know, $1,000 a minute. Over the course of a day, he's making $10,000 to $100,000. Over the course of a year, the guy walked away with a few $1 million doing this trick. So, and he's not alone. So he actually, I mean, this stuff, every time I looked at every company I looked at, we would find somebody who's doing this kind of shit. It was amazing how widespread it is. And it was simply not catchable by the manual techniques that the market had been doing for the last, you know, umpteen years. So it really is, like, there's a real crying need here for machine learning to do this job. Okay, I think that's the official end of the demo. The market replay is not currently turned on because I'll go in the story here. Neurensic has been, oh, why is this particularly illegal though? Okay, let me explain why this is illegal. This is a good answer. It's a good question. So I myself do not declare what's illegal or not. I hear somebody else tell me this is illegal, and so I had the same question you have. Why is that illegal? Okay, so imagine that you're going to go sell your house, and you know that your house is worth what? Well, other people will pay for it, right? So what will people pay for a house like yours? So you could drive around your neighborhood and you look to see what homes like yours are selling for. And you see, you know, lots of homes with a price tag on their front lawn, a for sale sign that says $1 million. So you go back and think, my home's probably worth $1 million. So you put a sign up on your front lawn that says, home for sale, $1 million. Well, guy walks up to your house the next day and says, hey, I'll buy your home. Oh my gosh, it's a quick, easy sale. You sold your home for $1 million. And you're moving out, and while you're moving out, you're driving through the neighborhood, and you see the same guy, and he's walking around the neighborhood, pulling up these for sale signs that were in these people's front lawns. Those homes are never for sale. And they were not for sale for $1 million. They were for sale for $1.1 million maybe, but you didn't know that. You thought they were for sale for $1 million. So he got your home at a 10% discount. That's a spoofing attack. He was putting out the intent to deceive you by making the appearance that the price was other than what the actual market price was worth. Then he doesn't intend to buy all those homes, or those people weren't intending to sell them. He pulls up, he cancels all his orders. So you look at the volume of cancels, and I can't read the tiny numbers. It's all his orders. He has a book of like 400 orders, and he canceled them all in one shot. And the market expects that if there's a large imbalance on one side or the other, somebody's got some knowledge about how the world's working that they're missing, and they assume there's an actual movement in the market price is pending, it's coming up. When that cancels, they back off fast. And then because they back off fast, the market rebounds, and they, the guy gets some sales in on the other side of the market at a 10% discount. Yeah, thank you. Yeah, great example. Okay, yeah, cool. Yeah, it blew my mind when I saw that first. Like the cross trading and wash trading, I get. Two guys are swapping a stock back and forth at the same price to give the illusion of volume on an otherwise stock that's not moving. Okay, they also do it at the last price of the day at some funny price because it changes the closing price for that stock on that day. So that's wash trading, and then there's there's a word for doing at the end of the day for trying to get the close price to change. And abusive messaging is sometimes called painting the tape, or it's like spamming the server. Basically, it's a DDoS attack on the exchange server. Those I get. Spoofing I didn't get, but it's like big money in spoofing. The other ones do not get big money. Spoofing, people make big money at, and that was fun. Fun learning it. And fun, putting together some ML to go catch it too. Okay, I guess we're solidly in Q&A if someone wants to ask a question here. Okay, I've got the same question. Are those strategies predefined, or can the user write their own? I answered that one a little while ago. Are you asking it again? Okay, Max is speechless. Okay, LLE, the behaviors are predefined by compliance officers who talk about what it is that's illegal and why it's illegal and why it seems to be an issue in the market. So people, there's what's illegal, and then there's what actually gets prosecuted and can be stopped. And so there's lots of interesting behaviors that are questionable, of which buyer beware, but there's some specific ones where people say, no, this crossed the line. And it's not me to define that. Having said that, the system is actually well suited for looking at large financial data sets and running them out. So you could do all kinds of fun strategy games. There's an obvious, hey, turn this on its head and go alpha with it kind of thing, except we're looking at post-trade data and not pre-trade data. The criteria for legality. No, the criteria for legality is defined by, like the CFTC, and I want to say, not the FTC, there's the SEC, the federal regulations. SEC. The federal regulators define what they consider to be illegal. Then different exchanges have another definition of what they consider illegal, because an exchange can kick you off from trading, and they'll do that if they think that you're hurting their reputation as an exchange, which will chase away other buyers from that exchange. Exchanges make money on the actual trade data. So they're all excited to have high frequency trading because more trades give them more of their commission. But they want the markets to be, at least give the illusion of fairness so people will continue to trade. Whereas the SEC is sort of the people, and the CFTC for the commodity side are the people who actually would go do the prosecution. And I'm gonna say they would drive a prosecution. I don't think they're not actually the prosecutors per se, but they're the ones who say this is illegal, it needs to be prosecuted, and they might go to the next step of going to, I don't know, the DA or whoever and say, we need you to go after XYZ person. You ask, the criteria is unusually vague. It's not vague to these people. That's a clear thing. It's vague to me because I don't understand it all. But I can find the patterns. But the guys who I'd worked with, including the government regulators, the people who are actually trying to enforce the markets, they had very specific ideations of what was legal and what wasn't. And so every time I brought to them some of this behavior up and said, hey, what do you think of this? They could refine it for me right away. Say yes or no, it's kind of wishy-washy, and they'd give me a score for it and say, look for this or that or whatever. I'd get fine-tuning constantly from these guys. So they had a clear notion of what it is to be legal. And the people who are trading seem to know that as well. So the market knows, the people in that market know what's good and what's bad behavior, and I'm just learning. Have I thought about using it? Yes. So there's all kinds of other interesting behaviors you could find in the market, and we totally did. We had all kind of false hits on what was legal or not, where we found interesting behaviors that were, everyone thought that was normal, it was okay. You would see all kinds of funny stuff. A lot of these log files would get post-processed because the format, they didn't want to hand out some other format, and they hand us some post-processed format, and we would find bugs in their logging and bugs in their formatting based on statistical evidence of, you know, what was or was not going on in the file. We could point out, said, hey, you have accidentally dropped all the following kinds of events. Or the following series always ends in a blah, which seems bogus. Maybe you messed up something here, or whatever. We found this all the time. So yeah, there's a lot of interesting behaviors you could find in there. So that's the obvious one. That's the alpha side, right? So like I said, this particular system is looking at post-trade data. It's different from a pre-trade data. There's clearly room to go forward here. I have definitely been in conversations with people about doing that. I myself am mucking around right now with looking at applying ML to markets to do, you know, to looking for a winning strategy. You're talking about actually what's called a speculative strategy, and that's one where you're trying to outguess people in the short haul, typically. So kind of use what kind of ML? So we tried a bunch of different things. In H things, I believe, including RNNs, but also you know, neural nets in general, and gradient boosted method, and distributed random forest, and generalized linear modeling, and a lot of, you know, PCA. Those dozens. Okay, fine. We tried a bunch, and we ended up with random forest as the better answer. So some of the other ones, because of this wild imbalance, 1,001 ratio of good to bad, you could just say it's all good, and you would be correct 99.9% of the time. And also somebody stealing a few $1 million annually, well, there are much bigger numbers than that getting stolen annually that I know are currently under prosecution. So big dollars get stolen annually if you go that route. So we went to random forest because it doesn't overfit. It's really hard to make random forest overfit. I think I talked to Ephraim before. He mentioned something about using, if you have multiple columns that are highly correlated, that will not cause RF to overfit, by the way, because it doesn't see all the data at every pass. Each individual tree does not see all the data, and that's the key to it not overfitting. So we tried deep learning for sure, but it was not, it was having issues with simultaneous over and underfitting. So we ended up with an RF. Real-time analysis. And would I use RF for pre-trade? Okay, so real-time analysis, the answer is totally. We had people driving us for real-time analysis, and totally we could get there. There's some mini batching things you have to do. A spoofing attack takes a couple minutes to build up. So probably instead of catching a spoofing attack, you would catch that some guy was doing back-to-back spoofing attacks, and then you could announce that somehow. Either have your own in-house trading algorithms recognize that there was a spoofer working whatever it was, you know, crude light or Apple stock, whatever, a spoofer working the stock, and they should get out, or you'll beware, right? We went to the market, to the exchanges themselves, who didn't want to admit that they had a problem, but the obvious thing to do would have them put out a signal saying, we believe there's a spoofing attack running right now, or they would cut off who they thought was a spoofer without declaring a spoofing. Like they're allowed to do this. Their exchange, they're allowed to say, Mr. Trader X, we find that your behavior is, you know, slimy, and so we're going to cut you off now for half an hour, or something like that, and then we'll let you back on if you clean up your act or whatever. They do that kind of thing from time to time. I don't know. There's something there about real-time analysis that makes sense for the exchanges, which would help everybody, makes sense for individual companies as a defensive mechanism to just like either stop it quick if they're doing it, because I don't know if people know this, but most of the traders are sort of free agents inside of a firm. The firm hands them cash, they go trade. At the end of the year, they look, the company takes their cash back, and then they split the profits. But the traders are basically free agents. So it is a requirement of a trading firm to police their own traders, but those traders come and go. And so there is a tension between the traders and the firms that are trading for them that you have to deal with. What I use RF for pre-trade, I have been using RF for pre-trade exactly because it's not overfitting, whereas my neural nets are both simultaneously over and underfitting. You know, if I do tenfold cross-validation, the RF's out of bag error pretty much gets close to tenfold cross-validation, whereas the neural net will give me a 99% answer individually and cross-validated, each one of them is getting 0. And so if I look at the cross-validated R2, R squared, it's essentially 0. And if I look at each individual folds, it's essentially 100%. There's like simultaneously over and over fitting to the max. It's completely useless. Yeah. I don't know. Casinos play a game where people have worked the math out, like in cards. So I don't know if people can read. I hope people can read the questions here. Is this type of thing applicable to casinos as well? Card games and the spinny wheel, whatever, roulette, that's all well understood mathematically. So the casinos have a 5% win ratio that's built into the mathematics that everyone just knows up front. You walk into a casino, your odds of winning are less than, they're 95%, not 1. Your odds are that you'll lose 5% of your money on average with a pretty wide spread. So the casino wants to spread really wide, so there's always a millionaire winner. But for every millionaire winner, there's 1,005% loser, right? Or losers spread out to lots of people. And the casino walks away with its 5%. Now, is there something else you can do with that? I would think ML, like the problem is so well mathematically defined, I don't think you need ML. I think people have done good, hard, deep studies on how these different games work and what the best strategies are and all that kind of stuff. Card counting is a different game. That's the casinos look for card counters by just watching people. There's some pattern you do with card counters that you recognize it, and there's some defense. You keep changing the deck fairly often to present the counted cards, the remaining known counted deck to be small enough that you can start to predict well. So I don't know if it applies to casinos. I would think not. I'm not a casino. Caveat emptor and all that kind of stuff. You can reach me at cliffc@acm.org. I wonder if I can do it this way. It's an easier way. I do look at LinkedIn. I don't look at it very often. cliffc@acm.org. Oh, share with slides. How do you want, the admin wants the slides. I'm happy to share them. How do you want them? I'll send them to your email. I'll send you an email. PDF file email. What are the next plans for me? I scored big finally in one of my prior startups. I am not retired, but I'm a loose cannon. And so I am, I want to move the camera to the middle, the screen in the middle. I may stare at it a little more directly. I am, right now I'm playing around a couple different things. Totally playing around in the stock market, trying to do some alpha gen, having some success. It's not tradable success yet, but maybe it gets there. It's been kind of fun. I'm doing this podcasting thing on the side. That's been a lot of fun. It's on my blog. I'm still in conversation with people, hoping I'll do like VMworks, make Python go fast. And that's a whole different story. And I would love to make Python go fast. I'll go to my what podcast? It's cliffc.org. Should put the final slide. Go there, and there's a podcast. And about a decade of written blogs, some of which are pretty interesting and relevant still. I would love to make Python go fast, but the Python core committee's been like gun shy from doing anything, and I guess they backed away from PyPy for reasons that never were clear to me. And PyPy has issues anyhow. But I could do to Python what I did Java if there was enough community support and money to fund me. That's out there. And I'll probably start a company again at some point and be the founder myself. I'm waiting to see if my game in the stock market pans out first or not. And if it doesn't pan out, I will probably go back in the startup game and find a startup I don't know doing what. And if it does pan out, I've got a new company then. All right. So that's sort of the future directions. How does trading technologies? Okay, so I am not legally allowed to say that. That's trading technologies will have to make that announcement. So unfortunately, I cannot say. I am no longer with Neurensic, by the way. So I'm a loose cannon, and I have been for a little while. And I wish trading technologies the best with the technology. I built some really fun stuff there. I hope to make good use of it. It was, like I said, it was a fun time for me. A lot of fun learning going on there. Thank you very much. You've been a nice audience. It's fun. Have a great day. Bye-bye.